This video is going to show you how to actually write a piecewise defined function. And to write the function, what we have to do is we have to identify the actual linear or the specified domain that we're graphing on, and then also be able to identify the equations. We're only going to deal with linear equations. So all of our equations will have a line. And in order to write a line, every line can be written in terms of, for a linear function, we can write all of our linear functions as y equals mx plus b, where m is the slope and b is the y-intercept. So we need to identify slopes and y-intercepts for each one of the lines, and then we can identify the specified domains that we're graphing on, and then it'll give us the equation. So notice I have two lines here, and for this first line, we see that the y-intercept of it is -1. So my b for the first line, b equals -1, and my slope, I can pick any 2 points on the line to calculate the slope. So this slope says I go up 1, 2, 3, 4 over 1, 2. So my slope is, and I'm going up 4, but I'm going to run to the left 2. So left means negative. So this is equal to a -2. So this line right here is just y equals -2x minus 1. That's the equation of that line. The slope is -2. The y-intercept is -1. On this other line, if I find the slope first, so pick any 2 points on the line, I can see that I'm going up 1 over 1, and I'm going to the left. So my slope, m, is equal to -1 over 1, which is just 1, up 1 over 1. So I can continue that out, and I can see that my y-intercept here, my b, is going to be at +4. So that line is y equals -x, which is -1 over 1, x plus 4. Now, the last part is to determine where the function is defined at. And we can see that there's a break in the graph right here at the value of 2. On one particular graph, it's closed. Here it's closed. And on one part of the graph, it's open. And that's because we want to keep the continuity of the function going. So closed means to include. Open means to exclude. So when I write this function, it looks like this. F of x is equal to. I want to create the pieces. Well, I have one function that is -2x minus 1. And f of x also means y, by the way. So I'm saying y is equal to -2x minus 1. And the other function is -x plus 4. Now I need to define where each one of these functions are. Where am I graphing each one of these functions at? Well, this one is being graphed from, we always read the graph left to right. And we're graphing, this arrow means go on forever, and you're looking at just your x's. Well, what's happening as you go on forever on these x's right here? It's going all the way to the left, which means you're going to negative infinity. And where are you stopping at? Well, you're stopping at the 2. So this is going to tell me that I'm looking at all values that are less than, and I need to look at this because I'm including it less than or equal to 2. So when I write my domain for x, all of my x's will be less than or equal to 2 on the green function. And on the purple function, they're all going to be, well, if I keep going in forever in this direction, all of my x's are going to get bigger and bigger and bigger as I go down like this. They get bigger and bigger and bigger. I'm looking at the x's again. They're getting bigger to the right. So there, all of my graphs, all of my functions are getting bigger. They're greater than, and then again, come back up here. They're greater than or equal to 2, and they're greater than or equal because this is a open circle. I mean, they're greater than, I'm sorry, not greater than or equal to, just greater than because we can't include it because that's a closed circle. So we just have x greater than 2. So this is how we write the piecewise defined function for this particular graph. All right, so we have one more example here, and notice this one has 3 parts that we're going to try to write the equations for. And so let's define those parts as a red part here to start it. We have a green part from here to here. And then we have a purple part here, right? So to write this equation, what we're going to do, we need to find the equations of the lines. Well, the first line, the red line, is just a constant function, and it's a constant at this y value here at 2. So this is just y equals 2. The next one, we need to find a slope and a y-intercept. Well, on the green function, we see that the y-intercept is at -2. The slope goes up 1 over 1, up 1 over 1. So the slope is just negative 1x. And again, it's up 1, you're to the left 1, that's y is negative. So this is y is equal to negative x minus 2. And on the purple function, again, you can calculate the slope first. So slope up 1 over 1, that means we can go this way, like this. And so the purple function is going to run like this, and it goes through 6 as your y-intercept. So this time your slope, though, is positive. So we have y is equal to x plus 6, or x, I'm sorry, minus 6 as the slope, as the y-intercept. Now, again, when we do this, though, we can see that this first function is being defined from negative 6 to negative 4, or from, actually, it's an arrow, so that means it goes on forever in this direction. So it's going all values that are less than negative 4. That's what that's telling me. So when we start writing this, remember f of x is equal to, I need 3 parts. I have a constant function at 2. I have negative x minus 2. And I have x minus 6. The first function, open circle, means we don't include that value on the line, right? And for this particular function, it looks like that you have it going from negative infinity, any value less than negative 4. So we write that as x less than 4. And now we don't know, I think this is supposed to be an equal to, actually. There's a dot inside of here. Yeah, let's do it like that. And then the next function, you have an open circle here and an open circle here, right? And because they're both open, we're not going to include on this next function. We're not including from this value, this x value at negative 4, to this x value at 2. So we write that like this. This will be from negative 4. Again, this should be a negative, my fault. Negative 4 less than x less than 2. And that means we're going to, on the purple function, we're going to include it here. And again, remember, I don't need this part. I just use this part right here. I use that part right there to find the y-intercept, but I need this as the actual function. And we see that it's starting at 2, and it's going on to infinity. So it's any value that is greater than 2. And again, we're going to close it on this function because we didn't close on the top one, on the green one. So that's x greater than or equal to 2. So here's the piecewise defined function for this. And notice, again, what we did, our process, you find equations. Once you have the equations, you can go and find the pieces that it's defined on. All right? So I hope this helps.